In this cracking video, we're going to take a look at how we configure OSPF between a Juniper SRX and a Nokia 7750 based on a VSR router. We will configure point-to-point OSPF for simplicity's sake between gig 001 on the SRX and port 111 on the Nokia device. And we're going to see one of the most common problems that we come across when we're looking at multi-vendor OSPF, which is the MTU mismatch. Very common to be asked this question in a written exam or have to deal with it in a lab exam. It's one of the real gotchas that they try and catch you out with. So the SROS box, the VSR, is connected to a virtual bridge on my server, and we're using port 111. So just to show you, the MTU on that port is configured to the maximum value, which is 9212, whereas the Juniper is going to default to using an MTU of 1518. So we'll take a look at gig 001, and we see here the Ethernet MTU 1518. So immediately that's going to cause us a problem. So just to be sure, we need to make sure we have IP connectivity between the two devices, make sure my underlying connectivity is working, and we do. So configuring OSPF is relatively straightforward on these devices. Usually if you know how to do something on an ALU or a Nokia service router, you can probably figure out how to do it on a Juniper device as well. The syntax is quite similar, looks different, but the command syntax itself is very much the same. So config router OSPF, and we're going to go with area 0 just because it's nice and simple. And we need to put our interface, which we have called J1, match J1. We're going to put that into the OSPF process. Now, because we're doing point-to-point link, we have two hosts only. We're going to set the interface type to point-to-point. That is something that has to match for the OSPF adjacency to come up. So now over on our Juniper, let's edit protocols OSPF area 0. And we're going to set interface gig 001 unit 111. And we're going to say interface type is P2P, and that should be enough for us to have connectivity. Now usually you want to put in the loopback on a Juniper and the system address on the Nokia router in order to allow your TCP based protocols to communicate with the logical address of the device, be that LDP, BGP, whatever. Okay, so show router OSPF neighbor tells us we're in exchange start on the Nokia device, to be expected. So I love switching between syntaxes or OSs. It's great fun. Here we're also in exchange start. Okay, so we have seen each other. We've seen our own router ID in the hello message from our neighbor. So we believe we have two-way communication. When we're exchanging the database descriptor packets, though, we're hitting a problem. So if we debug OSPF packets as a DB descriptor, configure log ID, let's go at 9 from debug to session, and we should start to see values coming in. Okay, so we undo the debug there. We can see our outgoing OSPF packet on the interface J1. We have an interface MTU of 9194. So that is 9212 minus our overhead. So 14 bytes of Ethernet header plus the 4 bytes of the 802.1q tag. If we look up here on our incoming OSPF packet over the same interface, we have an interface MTU of 1500. So the Ethernet MTU 1518 on the Juniper device minus the 18 for the Ethernet header and the 802.1q header, we have a mismatch. So how do we fix it? We need to match the MTUs. So on the Nokia side, we can do config router OSPF area, interface J1, MTU, right? MTU option there, and we're going to say 1500. full. Excellent. And it's as simple as that. Now on a Cisco device, you have the MTU ignore parameter, which is really just masking the problem. You probably want to fix it potentially if the adjacency forms and one router is sending OSPF information, like the database, across to the peer, and the peer is unable to support that MTU, then the packet or the frame is going to be killed.